The next talk in the historical series is by Bianca Castellanos. Bianca attended medical school at the University of Illinois Chicago and completed her pediatric training at UC Irvine. This was followed by a cardiology fellowship at Louisiana State Children's New Orleans. She came to Sick Kids last year for an electrophysiology fellowship and has since left us to take up a position as a staff cardiologist at UC Davis, California. Bianca's intelligence, work ethic and humour made a fantastic and long-lasting impression on everyone here at the Heart Centre, and we miss her presence daily. We hope you enjoy this talk on the evolution of intracardiac pacing as much as we did.
So I was asked to speak about the evolution of intracardiac pacing, and what I would like to do is go really far back in time and potentially end with intracardiac pacing to get a better understanding of how it is that we came to be where we're at today. At the end of it, I'll present a case of some newer technology that's in use in our pediatric congenital patients and touch briefly upon some areas of research for cardiac pacing. So this is a nice illustration from the main article that I'll be using to present the information. And I'll just point out that, even though this slide starts at 1950s, the concept of electrophysiology was described many hundreds and thousands even years ago. It wasn't until the 1950s, though, that we actually had the hardware in which to deliver stimulation to the myocardium in various forms. So let's go back in time. The earliest reports of cardiac anatomy, physiology, and electrophysiology. And the earliest report that I was able to find was in ancient China in 280 BC, which was in the works of Wang Shuhe, which was a physician of the highest ranks who wrote several books about the concept of the pulse. He referred to this concept of the spimos, and the concept was applied not only to the heart, but for various components of the body, various organ systems. And from this, the next reports I was able to find were in 384 and 322 BC, which was a comment or an observation, I should say, from Aristotle, who described the heart as the source of all movement, since the heart links the soul with the organs of life. Sort of a theoretical framework, but still quite relevant to today. And from there on, we had reports of 460 and 375 BC from Hippocrates, who described essentially the first possible reports of arrhythmias by saying that those who suffer from frequent and strong faints without any manifest cause die suddenly. And so we don't really understand what that was, but it could very well have been that these forms of arrhythmias were in the early stages of observation. Then later, Geronimo made some other observations. This may be considered the first connection between the pulse, the heart, and the concept of fainting. That was in 1580, where he gave a description of syncope as ubi pulsis id rara semper expectando es syncope, which is a rough translation of syncope as when the pulse is rarely ever expected following the collapse. Even still, we had a very good understanding of the heart's functions, although we didn't truly understand all of the electrical properties and how to treat. There were still reports of how to resuscitate a heart. There was a form of CPR described in the mid 15th century with one significant contribution from Nafiz ibn Iwad al-Karmani, I'm sorry if I mispronounced that, who was an Iranian physician and described the massaging of the left chest for individuals with, at that time, what he described as cardiac distemperament. And he was an individual who had come from a long line of physicians, practiced various different forms of medicine, and this practice had been in use within his family and was described in a book that was passed along to him. And that photo there is the scripture that was passed on from generation to generation. Um, in around 1600, William Harvey, who was an English physician, was attributed as being the first individual to achieve a mechanical cardioversion when he flicked the finger of an arrested pigeon's heart. The pigeon, then the heart began to pump or contract, and then he later went on to study and describe what we now know as a basic cardiac circulation, and that was in 1628. Keeping in mind now that the concept of electricity was not yet widely adopted, it was around 1752 that Benjamin Franklin made an observation that lightning seen in the sky had electrical properties and was electricity when he took a kite out, tied it to a string, and then tied the string to a key and observed that when lightning struck, that the key transmitted electrical energy. So then we have what comes after this observation. Some of his works were then used. He actually sold a lot of his personal goods in order to pursue the study of electricity itself. And from that, we had developments around that time of electrocardiography. Early electrotherapy also was even noted as early as the 1640s, and although well not described, as early as the 1774, there was some reports of external electrical stimulation of the heart in a young girl. So we don't know where that was or what the conditions were, but to say that there was some description as early as 1774 of this concept being used on patients. Various experiments were done on birds as well as other animals you'll see, which demonstrated not only the benefits but also the risks of electrical interpretation and delivery to the heart from here on outward. So some examples of these findings were noted by Nikolov Abelgard, sorry if I mispronounced that, who was attributed with the first example of the body's response to electrical energy in various parts of the body, so not just the heart. And he, in fact, successfully reported an electrical cardioversion in 1775. He did so by using a hen and attached the hen to these two electrodes. I'll just point them out. This is one electrode, that's another electrode, and it's attached to a generator where there's a crank, and so you have an electrical current that flows through these electrodes. What he did was he took these electrodes and applied them to the temples of a hen, and with that electrical charge, the hen fell dead, apparently. And then they did a series of another deliveries of electrical energy in various parts of the body, one of the places which was the chest. And when they did the chest energy delivery, they saw that the hen apparently came to life and walked away. So now we're getting closer to what we commonly know as the electrocardiogram, and some of these principles were taken from early experiments by Luigi Galvani in 1791 with his famous frog experiments, where he introduced the idea of that organic tissue carries electrical properties, and that delivery of electrical energy into organic tissue can cause a then contraction. And it was around this time that it was a lot of people had been working sort of together in various parts of the world, such that it was generally accepted that electricity had a pronounced effect, in particular with the heart. So we now have what we describe as the breakthrough, which came sometime in the 19th century. And in 1800, in fact, the first battery was reported by placing various metals together in a voltaic pile to generate a low voltage, high current stimulation. So not that much energy, but a lot of draw from that energy source. Thus, a measurement unit aside from that observed in nature, which was the lightning that we see in the sky. So now we can have sort of a man-made model of how to deliver this energy in the form of the first battery. And the measurement was then described after him, which is what we know as the volt. So in the 19th century breakthrough still, between about 1800 and 1802, Marie-François Xavier Bachat and Nistet reported several experiments where they had decapitated humans, and they applied electrical energy to the heart and observed that it indeed caused the heart to beat once again. And also in 1804, animal and cadaver models were being reported, which re-demonstrated this finding very consistently. And they described this finding as an alleviation to cardiac syncope. This is an example of one such revival of the cardiac myocardium in a decapitated subject. Keeping in mind, although this sounds dramatic, this was on the tails of the French Revolution, where death by decapitation was common, so the subjects were plenty. It's no surprise then that electrophysiology grew popular in culture and that the works of Mary Shelley could have been inspired very easily by observing some of these published findings. She, as many people know, published Frankenstein in 1818, which was a fictional depiction of revival based on scientific reports of bringing dead tissue back to life. So although it was published in fiction in 1818, it was later brought to reality in the century, which I'll proceed to describe. Frankenstein, as you all know, was the scientist, and the monster actually was not Frankenstein. And so her work became very popular and then was rewritten and has been made into many movies and plays. So these concepts were applied to our patients in the pediatric population when Duchenne de Boulogne in 1806 who was around 1806 to 1875 resuscitated a child who had drowned by attaching an electrode to one leg and then tapping the precordium with the other electrode. So there are some theories out there that this could have been very well could have been the first pacemaker, and it would have been the external pacing of the heart as early as 1875. So it was a unique case in about 1882, a unique case from a woman who had a large tumor in the chest wall requiring a very extensive surgery wherein her chest wall had to be partially excised. So the bony protection for the heart muscle itself was removed, and the impulses of the heart were seen just through a very thin layer of her skin. And it was von Zeisman who stimulated the heart in an experiment, the purpose of which to see if they were able to generate depolarization. So the tracings you see up there, although very scary, and if you think about it, just pacing the heart at any time can be quite dangerous, depending on the timing. So we were able to see that this actually does work and document also that there is an electrical change and an actual observe that the heart does indeed contract with that electrical impulse. So we now have a visual correlation both on paper and in the patient subject, which prove that electrical stimulation of the heart is effective. So in 1887, physiologist Auguste Desiré Waller is attributed to recording the first human surface electrocardiogram. So different from just a simple tracing, this had various characteristics that were described, which we are now knowing as the PQRST complex. And initially when he described this, he did not really attribute it to have much credit. In fact, he did a lot of his experiments, which he didn't think would apply to medicine at all, by using his own dog as a subject. And even in these cases where he published his works and spent many hours trying to accomplish these tasks, he didn't quite appreciate how widely we would be using it today. In fact, said, "I do not imagine electrocardiography is likely to find any extensive use in the hospital. It can at very most be rare and occasional use to afford and record some rare anomaly of cardiac action." And then in 1892, William Enthoven, who we all know is attributed to the Enthoven's triangle, which is the basis for calculation of electrocardiograms, introduced our basic understanding of the tracings that we have, as well as the bipolar electrode system. And interestingly, the electrical signal that was obtained was, so this gentleman here in the picture, he's got his arms in basically salt baths, and they're connected to a transducer, a recording system, and so it's pulling out the tracing. The gentleman is actually remote from where the tracing is being projected onto paper, and so it was essentially a long wire connected from the hospital to where the physiology lab was, and this is considered a very early example of telemedicine.